Lesson 19-3, page 978, 1 through 20. A cat has a litter of 6 kittens. You plan to adopt 2 of them. And how many ways can you choose 2 kittens from the litter? Well, what if we were to say, let's see here, we've got 1, 2, 3, 4, 5, and 6. All right, that's how many kittens we got. We could choose 1 and 2. We could choose 1 and 3. We could choose 1 and 4, 1 and 5, 1 and 6. We could choose, well, 2 and 1 would be the same as 1 and 2, so we'll say 2 and 3, 2 and 4, 2 and 5, and 2 and 6. 3 and 1 would be the same as 1 and 3. 3 and 2 would be the same as 2 and 3. So we're going to go 3 and 4. 3 and 5. 3 and 6. 4 and 5. 4 and 6. Or just 5 and 6. Okay, I believe that's got all of them. So how many ways is that? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. So 15 ways. 15 ways. I wonder if there's an easier way to do that. Okay, and that would be the combination formula. And if you go to your Inspire, we're going to go menu, 5, 3. We got 6 cats, and we're going to choose 2 of them. What do we get? 15. So this is 6 choose 2 equals 15. Not bad. Well, can we do this in the TI-84? And we can. Let's see, I think it's math, and then we're going to go over to probability and number 3. So let's choose 3, and we got 6, choose 2, and press enter, and we got 15. So we can do it in that one as well. All right. Number 2, an amusement park has 11 roller coasters. And how many ways can you choose 4 of the 11 roller coasters during your visit? Now see, now this would be getting kind of, it gets complicated after a few to do it the logic way. So the formula makes it much easier. So we're going to 11, choose 4. All right. And we'll go over here to the Inspire this time, and we got math, go over to probability, choose 3, and we got 11, 4, 11 choose 4, and that's 330. So that equals 330. Let's try Inspire. Menu, 5, 3, 11, 4, and 330. Excellent. All right. You can come back to this and see how to use the TI-84. I'm going to shut it down. It makes my computer run slow when I run them both. So I'm going to shut it down. 4 students from 30-member math club will be selected to organize a fundraiser. How many groups of 4 students are possible? Well, 30, choose 4. Menu, 5, 3, 30, 4. 24th 27,405. 27,405. Number 4, a school has 5 Spanish teachers and 4 French teachers. The school principal randomly chooses 2 of the teachers to attend the conference. All right, notice this says, what is the probability? Okay, so we have to find first the number of ways this would be successful. Okay, what is the probability the principal chooses 2 Spanish teachers? Well, there's 5, so we got 5 choose 2, okay? And let's see, menu 5, 3, 5, comma 2. That comes up with 10. So there's 10 ways you can choose 2 of the 5 Spanish teachers. Now, what's the sample space? How many different ways can you choose all of them? And you have 5 Spanish teachers and 4, so that's 9. We got 9 choose, and we're still only wanting 2. So that's going to give us 9 choose 2. Menu 5, 3, 9, comma 2. That's 36. So that's 36. Now to find the probability of A would be 10 over 36. It probably reduces to 5 over 18. Number 5. There are 6 fiction books and 8 nonfiction books on a reading list. Your teacher randomly assigns you 4 books to read over the summer. What is the probability that you are assigned all nonfiction books? So we've got the number of ways that we can do all nonfiction books. So that's going to be choose 4. Let's see. Menu 5, 3, 8, comma 4, and that's 70. And now the total number of books, the total sample space is going to be, well, 8 and 6 is 14, so we got 14 choose 4. Menu 5, 3, 14, comma 4, 1001. So the probability of being assigned 4 nonfiction books is going to be 70 over 1001. That's 0.0. I just meant to do that. 10 over 43. 10 over 43. And really probability would be done 0.67, 0.07. All right, that would be the actual. That's usually the way it's stated, not as a fraction. It can be, but it's not usually done as a fraction. 6. A bag contains 26 tiles, each with a different letter of the alphabet written on it. You choose 3 tiles from the bag without looking. What is the probability that you choose the tiles with the letters A, B, and C? How many ways what is probably that you choose the tiles with? And there's only one, okay? You could write 3, choose 3, but that's going to give you 1 as well. Menu, 5, 3, 3, comma, 3, 1. The sample space. How many different combinations of 3 can you pull out of there? That would be 26. Choose 3. $2,600. So the probability of choosing A, B, and C, I guess in any order, would be 1 over 2,600. Number 7. You are randomly assigned a password consisting of 6 different characters chosen from the digits 0 through 9 and the letters A to Z as a percent. What is the probability that you are assigned a password consisting of only letters? Round your answer to the nearest 1/10 of a percent. All right. So N of A, the sample space, that's going to be, how many letters are there? There's 26. And you're wanting how many? 6. So 26, choose 6. That's 230,230. That's easy to remember. All right, what about the sample space? How has that changed? Well, now we got to introduce the letter 0 or the number 0 to 9. So that's going to be 36. And we're still only choosing 6. $1,947,792. Was it 792? Yes. So the probability of choosing 6 as a percent, what is probably the sign pattern? 6 letters would be and we'll just I did that again. I guess I'm gonna have to write it. 1,947,792. 0.118. 0.118. So basically a 12% chance that you would get just six letters. Number 8. A bouquet of 6 flowers is made up by randomly choosing between roses and carnations. What is the probability the bouquet will have at most 2 roses? So at most 2 roses. So our sample space will be at most 2 roses. So it's going to be 6, choose 2 plus we got 6, choose 1, plus we got 6, plus 6, choose 0. Okay, all of that. Let's see here. Menu 5, 3, 6, comma 2 plus menu 5, 3, 6, comma 1 plus menu 5, 3, 6, comma 0. And that gives you 22. Now, why are you saying a bouquet of flowers is made up by randomly choosing between roses and carnations? What is the probability the bouquet will have at most 2 roses? Well, at most, that means the probability R is less than or equal to 2, which is 0, 1, or 2, which is why we have to do all 3 of these. Now, the sample space. The sample space. How many choices do we have? We have 2 choices, roses or carnations, and we're going to do this 6 times. So this is going to be 2 to the 6th power. Okay? So what do we got? 2 caret 6, 64. So the probability of no more R is less than or equal to 2 would be 22 over 64 0.34. That's 11 over 32, 0.34375. So we got, that's 11 over 32 or 0.3438343. Now, let me show you a little bit different way to do this one here. You can, since you have 2 choices, roses or carnations. Okay, since you have 2 choices. And that would suggest that there's a 0.5% chance of roses or a 0.5% chance of carnations, since it's between the 2. And you want less, you want 0, 1, or 2. R is less than or equal to 2. Okay, so the probability, success, and we're going to call this P. P is going to be 0.5. N, that's the number of trials, is going to be 6. Okay, so let's go to our calculator. And we're going to say menu. And then let's go to 5 for probability, 5 for distributions. And then we're going to go down here to B for binomial CDF. So we've got number of trials is 6. Probability of success is 0.5. The lower bound is 0. The upper bound is 2. We get the same exact answer. Ain't that cool? Now I need to show you, I need to show you how to find that on the 84. Because it makes things easier. Okay, do that on the 84. Second distribution, and then 2 for normal CDF. I'm sorry. Let's go down here and get binomial. B. So we're going to press enter. Number of trials, 6. Probability of success, 0.5. I got the wrong one. no, that is right. I did get the right, because it starts from the left and works to the right. So 0, 1, and 2, 0.34375, 0.34375. All right, so I'm going to keep that going for a little bit. All right. So number 9, bag of fruit contains 10 pieces of fruit chosen randomly from bins of apples and oranges. What is the probability the bag will contain at least 6 oranges? So that's going to be the probability that R is greater than or equal to 6, which is the probability of 6 plus the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10. Okay, so that's going to be all of those. 10 pieces of fruit. So N equals 10. Chosen randomly from bins of apples and oranges. So P equals 0.5. Okay. So how are we going to do this? In the Inspire, we're going to say menu 5, 5, 2. Our lower bound is going to be 6. I don't know why I did that. It's menu 5, 5, and then B, number of trials is 10. Probability of success is 0.5. Lower bound is 6. And the upper bound is 10. I get 3, 7, 6, 9. Okay. 3, 7, 6. Well, 3, 7, I'm going to put 0.377. So equals 0.377. Okay. Now, how do we do it in this one here? All right. So we've got second distribution to our lower. Oh, I did that wrong. Second distribution, we want to go down here to B. Binomial CDF. Trials, 10. P is going to be 0.5. X value, we're going to put in 5. And then paste. And then press enter. Now, what if we say 1 minus that? What do we get? 3, 7, 6, 9. Awfully darn close. 3, 7, 3, 9. What if I went up here and let me grab this? Maybe I should have put 6 in here. Put a 6 there. And then, no, that's going to be even worse. Oh, 376. That's what we had, 377, right? I don't know what I was thinking. So you see how the 84 works. The 84 works from the left, okay? It works from the left. So if you got 6, 7, 8, 9, that's going to be 1 minus the probability of R is less than or equal to 5, which is how you would do it in the 84. Okay, so that would be 1 minus 0.623, 0.623, which is 0.377. 7, 7. Okay? All right. Number 10, you flip 10 coins. What is the probability you get at most 3 heads? So we're going to look for the probability that R is less than or equal to 3, which is a probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. Okay, let's do it first in the 84. We got to find a couple things. N equals, and that's going to be 10. And then P equals 0.5. And that's because we're flipping a coin. There's only 2 sides to a coin, right? All right. So let's do this. Second distribution. And then, number of trials, 10, 0.5, and we're wanting at most 3 heads, so we're going to change that to 3. And we got 0.1719. 0.1719. Okay. In the Inspire menu, 5B, number of trials 10, 0.5, lower bound is 0, upper bound is 3, 0.1719. Excellent. Now, I'm going to shut this down again because it makes my computer run slow. All right. Now, what if we did it the other way? Okay, what if we did it the other way? Just to show you, you get the same answer either way. So we have N of A equals 10. Well, that's some terrible handwriting right there. We got 10 choose 0 plus 10 choose 1 plus 10 choose 2 plus 10 choose 3. All right. So let's go to Inspire. Menu 5.3. 10, 0 plus menu 5.3, 10, 1 plus menu 5.3, 10, 2 plus menu 5.3, 10, 3. I got 176. That equals 176. Now, the sample space. Again, we got a coin, so there's 2 sides, heads and tails. We're doing 10, so we got 2 to the 10th power. 2 caret 10, 1024. 1024. So the probability at most 3 heads would be 176 over 1024, and that probably reduces. (11 over 64). Hold a second. That looks different than this, what we got up here. Let's try that. Control enter. 0.1719. 0.7. Wow. You get the same answer either way. The binomial thing is just easier to me. Makes the calculations easier. Number 11. You flip a coin 8 times. what is the probability you will get at least 5 heads? So number 11, I'm going to leave for y'all. Number 12, you flip a coin 5 times. What is the probability that every result will be tails? Why isn't it wanting to move up? All right, number 12. You flip a coin 5 times. What is the probability that every result will be tails? So, probability, how many ways can you get tails every single time? N of A, that would be just one, right? Only one. What's the sample space? That's going to be 2 to the 5th power, which I believe is 32. So the probability of getting tails 5 times in a row is 1 over 32. Now, that doesn't really tell me a whole lot because, you know, my brain's just not figured. But if I go in here and I go 1 divide 32, get 0.03125 equals 0.3125. Now that tells me 0.3125. 0.3125. That tells me it's a very low probability. But, you know, let me check this other way. Menu, 5, 5. B, number of trials, 5. 0.5. My lower bound is 5. My upper bound is 5. I could have done menu 5, 5A and got the same answer. Menu 5, 5A. That's when you're just doing the one. Number of trials, 5. 0.5. And we're just looking for that one there. All right. So there we go. Same answer either way. Number 13. There are 12 balloons in a bag, 3 each of green, blue, green, red, and yellow. 3 balloons are chosen at random. Find the probability that all 3 balloons are green. Well, this ought to be fun. Find the probability that all, so how many ways can you get 3 green balloons if all you have is 3? That would be 1. You could say 3, choose 3, which is 1, but anyway. Now the sample space. We have a total of 12 balloons, right? And we're choosing 3 greens. So what do we got here? Menu 5, 3. 12, 3. 220. 220. So the probability of 3 green would be 1 over 220, which I know is kind of small. 1 divide 2, 0. And that's 0.0045. 0.0045. And those repeat. Now, let me ask you a question. Can we use that other model? We can. What do we got? We've got 3 each, blue, green, red, and yellow. All right. So if they each have an equal chance, there's 1/4, 0.25 of getting a green one, right? And a 0.75 of not. So N would be 12. P would be 3 over 12, which is 0.25, right? Okay. And we want to find the probability that all 3 balloons are green. So that's the probability of 3. Let's try that. Menu 5, 5, and we'll just use A. Number of trials 12, 0.25, and we're going to say 3. Ooh, what did I do wrong here? That's just 3. Hmm. 0.25. That did not work right. Why did that not work right? Probably. Oh, find the probability. All 3 balloons are green. Probability. I guess you can't do it that way. You're going to have to do it this way here. All right. We gave it a try. We thought we'd take the easy route. Number 14. There are 6 female kittens and 3 male kittens at an adoption center. And that's going to be on the form for y'all to do. You're welcome. 15. There are 21 students in your class. The teacher wants to send 4 students to the library each day. The teacher will choose the students to go to the library at random each day for the first 4 days from the list of students who have not already gone. Answer each question. So 15, what is the probability you'll be chosen to go on the first day? So N of A will be 20, choose 3. Okay, 20, that's 20, choose 3. Well, I'll say there's 21, but you're one of them, right? So there's 20 others, okay? And you could take any one of the 3 of those 20. So let's go here, and we got menu 5, 3, 20, comma 3, 1140. Now, what's the sample space? Well, that would be 21, choose 4. Okay, because that includes you. Menu 5, 3, 21, comma 4. 5985. 5985. That doesn't really look like a 0, does it? Just fix that up. Okay, so the probability of you going would be 1140 over 5985. That's 4 over 21. Huh. All right, good. 16. If you have not been chosen to go on days 1 through 3, what is the probability you will be chosen to go on the 4th day? Huh. So 4 went on the first day, day 1. Day 2, 4 went. Day 3, 4 went. And I count that, that's 12. Okay? That's 12 have already gone. So the probability, let's see, we got 8, choose 3. Yeah. Menu 5, 3, 8, comma 3, 56. 56. Okay, and that's 3 of the 8, or 3 of the people going with you, because remember you're the 4th. And then the sample space is going to be 9. Choose 4. and that includes you. $126. So the probability that you will be chosen to go, the probability of the fourth day you going would be 56 over 126. Four over 9. Number 17. Your teacher chooses two students at random in your homeroom. The homeroom has a total of 30 students, including your best friend. What is the probability that you and your best friend are chosen? That sounds like a good one for the form. 18. There are 12 peaches and 8 bananas in a fruit basket. You get a snack for yourself and 3 of your friends by choosing 4 of the pieces of fruit at random. Answer each question. 18. What is the probability that all 4 are peaches? Okay, N of A, all 4 are peaches. Well, there's a total of 12 peaches, so we got 12, choose 4, because it don't matter which one, well, it does, but maybe it does. Menu 5-3. You don't want the bruised one, do you? For argument's sake, we're going to say it doesn't matter. 495. 495. And then now, what about the sample space? How many pieces of fruit are there total? I got 20. So we got 20, and we're still only choosing 4. So we got menu 5-3, 20, comma 4, 4845. So the probability of 4 peaches would be 495 over 4845. 495 divide 4845. So about basically a 10% chance. That's the way the book likes to do it. 33 over 323. 33 over 323, which is 0.102. And we'll put a 2 there. All right. So 19 and 20 are yours. Okay. Great job. We'll see you hopefully soon, and you have a great day. Stay safe.